Hello everyone. So today we are going to discuss the next problem of our CSES problem set. So its name is trailing zeros. So here we have to calculate the number of trailing zeros at the end of the n factorial. So n will be given to us. Now let's talk about the intuition of the problem. I will. We have to calculate number of trailing zeros. So right, a number ending with zero is always divisible by 10, and 10 is formed by 2 into 5. So what I was thinking, like, if I am able to calculate the number of factors of 2 and number of factors of 5 in n factorial, so then whatever will be the minimum. For example, there are a factors of 2 and b factors of 5. So that means my answer will always be minimum of a comma b, because that much number of tens I will be able to create in n factorial, and that number of tens will reflect the number of trailing zeros. So this is the intuition of the problem. Now to calculate the number of factors, so before calculating, what we can do is, like, let me show you something. So here I will be writing n factorial. Here total number of 2's and total number of 5's. Okay, so let's create this table. So in 4 factorial, it is 1 into 2 into 3 into 4, right? So here I have already, like, 1, and from here 2. So here I am totally having 3 factors of 2 and 0 factors of 5. Now then next is 5 factorial. So 1 into 2 into 3 into 4 into 5. So again here I am having 3 factors of 2 and 1 factor of 5. Now then next is 6 factorial. So everything multiplied with 6. So from here I will get one more factor of 2. So that means 4 and 1. Now let's check for 7 factorial. Everything into 7. So since no new factor of 2 or 5 is added, so that means it remains as it is. Next is 8 factorial. So everything multiplied with 8. So now 8 will give me 3 more factors of 2. So that will be 4 plus 3 is 7. And this remains as 1. Now coming to 9 factorial. Everything is multiplied with 9. So this won't be adding any new factors for 2 or 5 either. So that remains 7 and 1. Now coming to 10 factorial. So everything into 10. So this will be adding one factor to both 2 and 5. So this becomes 8 and 2. So what I'm trying to show here is that number of factors of 2 are always greater than number of factors of 5. And if we continue the series, it will always remain greater, because, like, basically a factor of 2 is adding all at an alternating numbers. For example, 8, 10, 12, or 14. So this will always give me at least, I must say, at least a factor of 2, because, like, 12 will give me 2 factors. So all the alternating numbers are even, so that will be giving me at least a single factor of 2. And to get the factor of 5, I must wait for like 5 steps. From 10, after 10, the next factor will always be at the 15 factorial, because 15 will give me the next factor. And after 15, I will get the next factor at 20. And between these numbers, there are, like, three even numbers: 16, 18. Okay, 60, two even numbers, 2 or 3 somewhere. So that will always be adding to the number of factors of 2. So what I'm trying to point here is that if I calculate the number of 5 factors of 5, so that will always be my answer, since it is always less than the number of 2 factors. Okay, so let's code up the solution. So long n, c in n, and let me take answer as 0. So to calculate the factors, I will be starting with I is equals to 5, I less than equals to n, and after each iteration I will multiply the I with 5. So factors will be, number of factors will be answer plus equals to n by I, and see out answer and so I hope it should work for 20. Let's check. Okay, So let's submit it once. Yeah, so it got accepted. Okay, so like let me take a example. So I'm taking 395 and let's try run it, like whether we are able to do it or not. So if n is equals to 395, so I need to calculate the trailing zeros at the end of 395. Let's take this code also. Okay, wait. I'm not getting how to move this. Okay, so here I've got the code, and now let's try it for the case n is equals to 395. So we are starting with I is equals to 5, and to check the number of fives that are occurring in 395, so we will divide it. Currently the answer is 0, yeah. So 395 upon 5 will give me the number of 5 raised to the power ones. So that is, like, if I divide it 7 times and 9 times. So currently I have 79, and now I am multiplying I with 5 to check for 25. Yeah. So now you must be wondering, like, the number of factors which I will be getting on dividing it with 25 should be multiplied with 2, because there are two factors in 25, but that's not the case since we have already divided it by 5 before. So all the factors of 25, there one 5 is already counted and we need to count the remaining 5. So we will simply add it without multiplying it with the factor number. So yeah, so if I divide it by now 25, so this should give me, let me check, 395 divided by 25 is, it's 15.8, so which is like nearly 15 it is giving me. And now next, it, we have to calculate for cube again. It will give me all the numbers which are in which I am dividing it by 125, so which are total number, total number of times 125 will be there, but out of which I have already calculated for 5 into 5, so only a single 5 is left. So to calculate that, we will divide it again, 395 with 125. So it is giving me as 3. And now for 5 raised to the power 4, the iteration stops, as now this number is greater than n. So if I add it, 79 plus 15 plus 3, So it gives me answer as 79 plus 15 plus 3, 97. And as we can see, we are getting 97 as the output. So the time and space complexity for this will be, space is O of 1 since we are using only a variable to store the answer, and the time complexity is like near about log to the base 5. Yeah, log n to the base 5. Base 5 because at after each iteration I am jumping, multiplying the I with 5, and I is going up till n. So my series is like going from 5, then 25, then 125. Yeah, so it's log n to the base 5. So this is the time complexity. So that's it for today's video. Thank you.